Once again, we had to go through some of the concepts fairly quickly in class, and so I want to address some of those concepts in a little bit more detail in a series of informal videos. Those of you who are with me in EDRM 710 know that I used videos there for my main lectures, and those had transcripts, and I spent a lot of time producing those. These videos that I've been making from week to week are very much informal. No transcript, I'm just talking and just trying to help you explore concepts a little more in depth. By the way, if you did not have me for EDRM 710 and would like access to those EDRM 710 videos, just ask me and I will get you access to those in case you want to go review any of the concepts. So I'm actually going to start here. I've got a blank screen up because I want to put in some formulas or some words. I want to start with the concept of mean squares. So the idea of a mean square is simply that it is variance. Now, if you had me for EDRM 710, when we talked about variation of scores, we primarily focused on standard deviation. But there's also a statistic called variance that is just the square of the standard deviation. So let me show you how that works. Here I'm going to create a series of scores. I'm going to make this a real simple data set, real short, just to illustrate some concepts. So I'm just going to call them scores. I'm going to put in a few scores. Okay, so I have put in, 7 scores here. Remember that when we talked about variability when we were first learning about it, that we started with deviations from the mean. So we have a mean of these scores. And let me go ahead and run these to create these objects. So down in here in the environment, you can see our scores, and you can see the score mean is 83.9. So some of these scores are below the mean, some of these scores are above the mean. If there was no deviation at all, they would be right on the mean. Let's create the score deviation. Okay, so here again in the environment, you can see some of the deviations. The score of 72, which is the first score, is 11.86 below the mean. So that is its deviation score. The more deviation we have among the scores, the more variability we have. So we talked about that as a very early EDRM 710 concept, and we said we wanted a statistic in order to measure variability. So what did we use as our statistic? Well, what we did was we took and created the square of all the deviation scores, and then we divided it by the degrees of freedom. If we had just taken the deviation scores and added them all up, actually let me do it over here instead of putting it in the script, let me do it in my console. So I'm going to add up the deviation scores. We see that we have essentially 0. Well, that might not look like 0 to you, but that's just rounding error. If you look at it closely, notice the e to the negative 14. So that means that there's 13 zeros in front of this 2. So it's 0.0000, and you got to say that 13 times, 284. Basically, it's 0, but this is a little bit of rounding error going on, because even like humans, R has to round as well. It doesn't take everything out an infinite number of decimal places. So if we were to look at the sum of deviation scores, it's not going to help us understand variability. It turns out to be 0. And the reason for that is as you can see down here looking at the deviation scores, we have some of them that are negative and some of them that are positive, and they cancel each other out. So what we do, instead of taking an average of deviation scores, is first of all, we square them all. By squaring them, large deviations, regardless of whether they were under 0 or above 0, large deviations will become large positive squares. So let me go ahead and take the square of these deviations. And we can see that when we look at those, that they're all positive numbers now. And this is what we're actually going to focus on. Now, here's a term you did not hear in EDRM 710, but you heard it plenty of times in EDRM 711. We're going to take those squared deviations and add them up, and that has a name. It's called sum of squares. So I'm going to call it SS deviation for sum of squares deviation, and that's just going to be our sum of the squared deviations, and that number turns out to be 764.8, about 6. If we then take those squared deviations and divide it by the degrees of freedom, which is 1 minus the number, or number of scores minus 1 less than the number of scores. And if you don't know about the concept of degrees of freedom, you should have learned that in the first statistics course. Go look it up on the web or go back to my video where I discuss it. The reason we divide by the degrees of freedom instead of by n is because if we divide by n, we're using redundant information. And so we have to divide by n minus 1 because those are all independent pieces of information. And a true average is based on dividing by the number of independent pieces of information you have. So if I take that sum of squares deviation and divide it by n minus 1, first of all, let me go ahead and put degrees of freedom is going to be n minus 1, which in this case is going to be 7 minus 1. There are 7 scores. So the degrees of freedom is 7 minus 1. And so now, if I take the sum of squares and divide it by the degrees of freedom, that's the variance. And the variance has actually a special name. We call it mean square. So I'm just going to call this mean square of the I don't even have to say of the deviations, just mean square is simply sum of the squared deviations divided by the degrees of freedom. That's what a mean square is. And the mean square is 127.48. Statisticians sometimes refer to a mean square as variance. And if you were to take the square root of variance, or the mean square, let me just do it over here. Take the square root of the mean square. That's 11.3. Well, what is that number? Well, watch this. The standard deviation of the scores, 11.3. So the square root of mean square is a standard deviation. So what we have done is we have looked at standard deviation as mean square divided by degrees of freedom, where, as mean square root of mean square, So the square root of mean square is the standard deviation of 11.3, and mean square is just the sum of squares divided by degrees of freedom. So that's the key. Mean square is going to be sum of squares divided by degrees of freedom. Okay? All right, now this is all leading up to something, of course. We're not going to drop it off right there, but that's the basic original definition for mean square, and it's related to a 710 concept, because if you take the square root of the mean square, that gives us the standard deviation. Conversely, if we square the standard deviation, let's go back here, if we take the standard deviation of scores and square it, that gives us our mean square of 127.47. But go back through this and study it. Get so that it's second nature for you, that all we're doing is taking deviations, squaring them, adding them all together, that sum of squares, divide that then by the degrees of freedom to basically get an average of those sum of squares, and that's the mean square, which is the square of the standard deviation. Okay, I'm going to have a part 2 because I see that over 10 minutes has elapsed. And in part 2, I'm going to talk about the fact that we have 3 kinds of sum of squares. You already know that. But what that means is we also have 3 kinds of mean squares. So I'll see you over in part 2, assuming you're going to stick with me for this.